Okay, thank you, Harnett. So welcome everyone. As per the introduction, I'm Derek Harnett, COO of Switch Automation, and we're a platform that provides decarbonisation solutions for the built environment, and that's what we're going to be talking about today. If you have any questions, as previously stated, just throw them into the chat, and we'll get to them towards the end. And hopefully the bring you some new learning and an introduction to how we can make buildings better. So my background is in building commissioning, and predominantly in the biopharma sector. So I've spent at least 25 of my 30 working years in biopharma, and many of those in Singapore, working with GSK, Pfizer, MSD, Wyeth, to name but and helping them to commission and qualify their facilities. And one thing that's always frustrated me on that journey is the fact that once we brought a building online, then the performance of the building isn't always kept the way it should be. Now, with the process systems within the pharmaceutical industry, obviously they have to stay in the same way as they were commissioned, but the turnkey buildings, the warehousing, the offices, and so on, they don't get kept up, and there's a huge environmental impact on the performance. So I see that our poll has landed at exactly the right time for my first slide, which is funny, but anyway, feel free to answer the poll as we go through. So 40%, that's the total impact of the built environment with regard to the CO2 load. 27% of total emissions come from the operation of buildings. So the HVAC systems, the aircon, the lifts, the lighting, the power, all of these things contribute to nearly a third of the world's global emissions. So when people look at flying, they look at aviation, shipping, transport, and normally that's the main source of the carbon. So actually, built environment is a major source, and it's invisible. People don't really see it, so they don't think about it. So 2/3 of the buildings that we have today will still be here in 2040, and 50% of the buildings that are here today will be still in use in 2050. Now, the way those buildings are constructed, the materials that are used, and the way they're run, and the manner in which they're operated cannot continue if we are to hit anything close to the 2-degree target or the 1.5-degree target that's been set out by COP. So what we have to do is not knock down all of the existing buildings, because if we do that, we're going to release all the embodied carbon that's in there, and that won't offset the nice shiny new carbon neutral building that you put up to replace it. So we have to find a way to make today's current buildings relevant in 2030, 2040, and 2050, such that they're polluting less, and they're contributing to a better outcome. So there's lots of ways we can do this by improving the operations. We can improve the equipment that's used in the building, so we can move towards electrification where we have renewables available to power those systems, and we can optimize the way the building's used so that we're only heating or cooling the elements of the building that are actually in use, because the usage has changed drastically over the course of the pandemic, and now with a hybrid environment, buildings aren't being used anywhere near the capacity that they were originally designed and commissioned to deliver. So we have to find ways to improve that, and you do that through the process of digitalization. So the drivers that we see coming through is regulation, very much so, less so in the pharmaceutical industry, but certainly for commercial real estate, we have a lot of regulation coming down the line. In the UK, they've adopted neighbours. In Europe, they have EU taxonomy. In the US, they have New York's local law 97. all of which are driving companies to have to report their impact that stops them from being able to greenwash their reporting, and they have to actually have hard data to back up the claims they make about how much, how green they really are. You've also got the investors. They're driving the market to be greener. They don't want people talking about it. They actually want people to act. So in order to get the funds to invest, then you have to have a solid green plan. And then lastly, you've got the office of the buildings ourselves. We want to know that the space is healthy, that there's no heavy viral load in the space. And currently the landlords aren't always geared up to be able to give that data to their occupants. The data's locked away in a BMS somewhere, and it's not accessible. So what we aim to do with a digitalization program is to put the data back in the hands of not just the owners and operators of the building, but also the people that live, work, and operate in the building. And to do that is by breaking down silos. Those of you who work in and around the building operations will know that we have lots of systems, particularly in the pharma industry. All of those systems are disconnected. So the BMS system doesn't talk to the access control system. It doesn't talk to the elevators or the vertical transport. It doesn't talk to the fire alarm system or the lighting systems. And as a result, you don't get the opportunity to bring the data into a single place and start to optimize the building, not based on one metric, but on many metrics. And once you start bringing all of your data into a single source and normalizing it, then you can add a lot more intelligence into your operations, because you can see not just a temperature is high or a CO2 level is high. You can understand why it is, because maybe there's too many people in that meeting room, or the aircon wasn't optimized for the use case that's being employed because they've changed the use of that space. And this is something that happens on a very regular basis as buildings grow older and the use changes and the needs of the organization change around it. So what you need to do is break down those silos, bring all of your data into a single source, and then start to normalize it and build up the relationships so that you understand the connectivity between a terminal VAV unit in an office space and the air handling unit that's providing air to it, and the chiller or the boiler that's providing heating or cooling to the air handling unit that's serving that space, so that you can look at the data holistically as opposed to just at a room thermostat level, which is how it's done today. So in order to do that, you need the independent data layer, and that's the data aggregation and normalization aspect of the digital journey, where you connect either directly to the network or via API or MQTT calls, which is where you have the data is already coming from something along the lines of an IoT sensor, and it's going into a cloud, and we or companies like us can pull the data from the cloud and bring it into a single place, because currently those systems do not get connected into the BMS, and there's no way for the building operators to bring all of the data into a single source. So they need an independent data layer that's secure, that's stable, it's robust, it's always on, and it's normalizing the data such that it can be useful for all the different groups within the operations of a building. So it's not just the maintenance team or the facilities management team, it's also the sustainability team and the management team need to understand how much their building is costing them in terms of energy, how they can save money intelligently by using the data that's already available, but currently not open to them because it's locked inside a life safety system, or locked inside the lighting system or the BMS. So the idea is to surface all the data, normalize it so that it looks the same, and then build the relationships between the different systems such that you can have an intelligent approach to treating the data. So there's lots of different ways of doing this. You start by bringing the data into a single source, and then once you've brought the data in, you've normalized the data, and you've done your equipment tagging and sorting, then you can start to apply analytics and logic. And what these do is they act as a form of what people would call AI, but the reality is it's machine learning and basic algorithms that basically teach the platform to look for anomalies, look for outliers within the building performance, and surface those events automatically so that you don't have to have a person sat in front of the screen waiting for an alarm to trigger before they take action. So the intention of a digital lab is to give you the insight to avoid an alarm or alert and deal with the problem before it becomes an issue. Once that's done, you can deploy your workspaces, which is dashboards or visualizations, dependent on who you're talking to. But essentially, it's that single pane of glass that's sharing the data and making it useful for the different personas within the company. So, as I say, you can go from the C-suite, who have very high-level portfolio interests, down through the sustainability group, who need to be reporting on the impact of each of the buildings within their portfolio, and then down into a building level where you have the operators, the tenants, and the maintenance teams who are also using that data, but for different reasons. You can use the platforms such as this to generate automatic reports. So in the pharma world, you're always having to do your periodic reports and your reviews. A lot of the data that's pulled from those can actually be done automatically. So you have consistent reporting. You're not relying on people downloading screenshots from the BMS and downloading screenshots from the RMS and putting them together into a Word document and making copy paste errors. You can have those reports automatically generated in the format that you need. The end game for us, at least, is autonomy, where we can actually control the building based around what's happening either without, in terms of the environmental conditions, or within, in terms of occupancy and usage. So dynamic control is an area that's going to become quite standard. At the moment, it has a low rate of adoption because people fear change. And along with the advent of self-driving cars, the thought of operating buildings is something people can't always get their heads around. But it's going to be the buildings are eventually, and we're already starting to do light touch automations around occupancy control and response to occupancy and weather events that can automate the set points and the operational parameters within the building. So this is something that's coming, but it's a slow to adopt because people fear change, and particularly in the pharma world, we know that nobody wants to be the first person in front of the FDA with a new idea, but also nobody wants to be the third guy through the door either, because they're going to be late to the game. So it's about having the confidence to take the data, trust the data, and then use the data to map out the path to improving the building operations. By doing so, you're going to reduce the energy consumption, and by turn, you're going to reduce your carbon impact. There's lots of different use cases. Obviously, the audience today is mostly considering pharmaceuticals and life sciences industries, but to us, a building is a building, so the data is pretty much the same regardless of where it's coming from. It's just about how you normalize the data and how you use it. So the integrations between the different buildings and the different systems in the buildings is where the digitalization really comes to bear its real power, because you can start to have interactions between different systems whereby you can automatically generate a work order that gets sent to your maintenance contractor so that you can reduce the load on your facilities management team. You can track the progress of those work orders back through the platform, and then you can have your KPIs, not just in terms of the performance of the building, but also the performance of the teams working within the building in terms of how long it takes a different group of people to close out a work order, how long they process it, how much it costs them to process it, and that can change how you actually manage the contracting of your vendors and your maintenance contractors. And that is leading to a shift in the way that people maintain facilities. So before you can do anything, you have to have the data and you have to trust the data. You need to be able to understand what's connected to the network. You need to be able to trust that what you see on the network is everything that's there and there's no gaps, and you need to be able to scan it to make sure there's no changes on a regular basis, because in a living building, especially where you have occupancy changes, you get systems connected, disconnected, and the as-built drawings are never always kept up to date. So it's very difficult for the operations team to know what's connected to their system at any given time. So having the ability to scan the network on a regular basis and understand if there have been any changes between the first scan and the next can give the team good insight to where they might be having some problems. So we touched on the earlier screen about deploying logic and analytics. This is where platforms such as these really come into their own, because the BMS is generally programmed in a very manner whereby there's certain conditions to be met in terms of set points. And as long as those conditions are met, the system doesn't look at how they're met and whether they're being met completely. So having the ability to do deeper analytics, anomaly detection, and comparison across systems allows you to see if, for example, one area is meeting its temperature criteria, but every day or every week you can see that the chilled water valve is having to do a bit more in order to be able to deliver those conditions. You can see that the filter on that valve is possibly choking up, or maybe the actuator is failing. So you're getting the insight and you're getting alerts into these things in advance of an actual failure. So you're not waiting until your temperature is no longer met. You're able to address the issue in advance of that, which means less downtime for the systems and a better satisfaction from the operators and the occupants, because they're not having to complain that things are not working. It also gives you much better intelligence in terms of which equipment is regularly failing, which equipment is more reliable, so that when you move to your next project or your next building, you know which equipment to specify, because you've got solid data behind you to help you make those decisions. So the most important thing is having that data available, and then finding the use case that applies to the different persona that you're talking to. So having the ability to surface the data in a manner that suits your clients and suits the needs of the particular user varies from, as I say, from the C-suite through the operators, through the maintenance crew and the occupants. They all want to see a slightly different element of the data, and you need to be able to deliver that to them in real time, so that anytime they need to check on the system, they can see the data that's relevant to them, and they don't have to scroll through pages and pages of BMS screens to find the information that's important to them. So I touched earlier on automation. This is going to be the future, but the future is actually here today. So we're able to do automated control based on CO2 levels, based on occupancy levels, based on lighting levels. We can control many things, and you can only do that once you start to link all the different systems together. So the intention is having every system within the building connected, integrated, and brought together in a manner that you can have two-way communication, such that if you see the CO2 levels in a particular meeting room are going outside of the acceptable range, you can put more fresh air into that space and ensure that the people in the room aren't getting underserved in terms of their oxygen levels. Conversely, you can turn off a space or turn down the set points on a space that isn't being occupied, and you need these integrations and these levels of connectivity to be able to deliver that functionality. But that's the way things are moving at the moment, and it's for us it's a very exciting future, because we can have buildings that really adapt and meld themselves to what's going on in the building at any given time, as opposed to just running 9 to 5 Monday to Friday, or in the case of an operational facility 24/7 when there's nobody in the space, and yet all the clean rooms are still at 18 degrees and 20 or 30 air changes when they could actually be much lower, saving considerable amounts of money. So as I said earlier, reporting is a large part of what we do, but the main focus is being able to simplify the reporting for the users, so that if you're doing periodic reviews, if you have an audit coming up, you have standardized reporting that's available, that you can go into the system, you can select the reports you want and either download them as a PDF, or you can have them emailed out on a month or weekly cadence, whichever suits the requirements of your organization. And the reports are there formatted in the manner that suits you, and having the data to hand that's come from real-time data, not static data that was downloaded maybe a week or a month ago. So you've always got the appropriate knowledge on hand to be able to give insight into what's happening in your buildings. So this should not be there. I do apologize. Those slides are supposed to have been taken out. So I'll open to any questions now, and hopefully we got some coming through.
Hi, Dave. Can you hear me?
I can hear.
All right. I have loads of questions. So
always the first.
Well, I want to break the ice. If anybody wants to beat me on the first question, they're welcome. No, so maybe for the because we work together a lot in the pharma, and I know that you are doing an assessment when you enter a new building on how ready the building is to go to that digitalization mode. And from your experience, we think we are well connected in the pharma, right, with all our sensors. How ready is a pharma building compared to an office building or a shopping mall, and which one is generally the easiest to go to what you present and to the next step?
So how ready? Okay, the expectation is always that a compliant facility such as a pharma facility would be more ready to take this journey. The reality is the silos are still there, especially where you have the breakdown between qualified systems and unqualified systems. So we all know, or anybody from the building services background knows, that the BMS system never gets as much love as the QBMS or the RMS or the EMS, depending on who you work for. So the qualified systems that are monitoring the building have much more attention than the non-qualified systems that are operating the building, which I always found to be quite disconcerting. So what you can do with these kind of platforms is have that overview where you're bringing the insight from both of those together. So in the terms of an environmental monitoring system, you can see that your space has gone out of temperature or out of pressure, but you're not seeing why. You have to then go across to your BMS to understand what's happened. Is the VAV sticking so that the pressure's dropping off because there's too much being exhausted out of the room? Or has the supply side failed and you're not getting enough air into the room? But you don't see that in the RMS. All you see is that you've got a deviation that you now need to write a report for. Whereas having an overarching system like this, you could see that the VAV is stuck and this is why my pressure's changed. But more importantly, you can start to see that VAV has been changing its performance and operation against its standard delivery over a period of time. So you can see the failure coming, and then you can set thresholds as to when you want to trigger an alert to get a technician to go and check that. So in terms of availability and connectivity of data, I would say that the pharma facilities they have a lot more data available, but whether it's as easy to connect to, I would say no real difference. In a commercial environment, you have restrictions from the IT team, which you would get exactly the same in pharma. So I'd say the reality is that sadly, it's probably just as difficult to connect in a pharma environment as it is in a commercial one. The only difference being once you do get connected, there's a whole world more. There's a lot more data available, which means there's a lot more insight that can be brought to bear, and therefore there's a lot more enhancement and improvement that's available.
don't know if we have a question in the chat. I think the only chat we have is Christina. We can ask question in the chat. Yeah, welcome anybody else. Otherwise, I will keep asking questions for the next 30 minutes.
Hi, Derek and Pierre. Honghang here.
Hi, Jake.
So I have one question. Like, in a pharma facility, for example, like biologics, like what are the areas you can see is like with the low hanging fruit to reduce the HVAC energy consumption, like laboratory, shop floor, or clean room?
Yeah, there's massive amounts. In all of my career in pharma, I only worked on 2 qualified facilities that actually had a turn down or a night setback mode, whereby they reduced the air change rate when the facility wasn't occupied. Now, the commissioning and qualification process was much more complicated because you have to commission and qualify each of the different modes, and you have to demonstrate that as it switches from one, goes back to the other one, you don't get any deviations, you don't get any reverse flow, or you don't lose your pressure cascade. But it's absolutely possible to do it. It's just very few designers want to be the ones to put that in front of a client, and very few clients are willing to take the risk. So you have a facility that's running 24/7, in some cases 50, 60 changes an hour, massive amounts of energy that just don't need to be used. And as a low-hanging fruit, it's massive, it's so huge. And it's very, very frustrating. And Pierre knows this because we've tried in the past to do studies and to work with clients to encourage them to take the first steps down that path to having a more responsive control, because especially when you're talking about biologics, the process can take many months from initial formulation through to the product being ready. So some of these rooms people don't go into for days or weeks on end, yet still they're maintained in a condition as if they were occupied. And that makes absolutely no sense at all. So if you're looking to decarbonize, then that's a very, very fast win. When you take it to the next level, that's when you start looking at your processes and seeing where you get peak loads in cooling, because you're running a lot of Wi-Fi. You need to run through the heat exchangers. If you timed all of those properly within your process, you could also optimize and reduce the chiller usage, or conversely the boilers, depending on what you're doing with the heat exchangers. So there's a lot that you can be done to bring the process and the building together in order to improve and enhance the performance. And for me, operational excellence is the way to do it. It's by really looking at the true process, or not just looking at the room conditions and the room temperatures that need to be met. It's what's the other things around that have an impact on it.
Yep, thanks, Derek.
Well, Derek, because you mentioned that project, what I remember from the project, one of the real challenge was the data structure we were getting to understand which data was what and things like that, because we, between extracting data in an Excel and then retraining them. One challenge today when you try to have that data layer that you are showing in your slide, to be able to understand what data you're receiving, right? What do they mean? How do you make that work? What are the basic steps you would have to do, and how much is that journey compared to the analytic of the data?
Yeah, so good question. The first process, once you started ingesting data from any building, is data commissioning. So we have to make sure that what we're getting from the system is correctly tagged, the values are correct. When you're dealing with analog outputs, is it a 1 or a 0? Does 1 mean alarm, or does 1 mean no alarm? And quite often these things haven't been set up correctly, because most BMS systems, although there will be a naming convention designed by the design consultant, the application of that is a bit looser with the engineers themselves, and they tend to program using whatever they've been trained on initially, so they don't always follow the same methodology. So the first point is data commissioning. So we need to know that the information coming into a platform is robust and reliable, because any analytics you run off of it have to be, if you get if you get nonsense data in, you're going to give nonsense analytics out. So the first thing is the data commissioning, and then the application of naming conventions such as brick ontology, which is becoming an industry standard. There's several out there. There's also Haystack. Facebook are trying to build their own one. Google are trying to build their own one for their boss. But one of the ontologies will settle out, and the rest will become Betamax. And at the moment, we believe that brick will be the standard ontology, and that means that you can build a solid relationship between all of the components within the building, such that you can apply much more advanced analytics and logic in order to make sure that the data is solid. So you're doing a second validation of the data by looking at the rest of the data around it as well.
So if you had a new project, a greenfield or facility, then is that something you will put in your spec, and which, you know, you could say, I want this to be structured like that, and is that something like the ISO you can download from somewhere or you can refer, so that, you know, even if you don't do the analytic today, at least the data structure is there for when a company come and try to do the data analytic?
Yeah, absolutely. So, I mean, it's become fairly standard. You know, anybody that's worked on, say, a Jacobs project will know that anything that starts with XP is a valve, you know, a hand valve. MV is a motorized valve. So the naming conventions are already kind of there within the design houses, but they're not implemented globally. And on the next level above. So you're not just saying that you're a manual valve, you're saying you're a manual valve for a heating system connected to this system on this line. And it's essentially like when we used to have to do a red line and we walk down the system with our highlighters and we're marking up the thing. What we're doing with the ontology is exactly that. You're linking that whole system. So essentially you're building a digital twin, not in the graphical 3D models, but in the way that the data is connected for the systems. So that's really important for getting, as I say, getting the advanced analytics in place.
Is not that what BIM is supposed to do? Sorry, I don't. What's the difference between that and BIM, right? Don't say.
So BIM, yeah. How many projects have I been on where BIM was successful? I can't count. The last project I did in Singapore before I moved to my current role was a very large development, urban redevelopment in Paya Lebar. And the first thing I noticed when I walked into the project office was a box in the corner full of iPads. And when I asked what they were for, I was told that they were the BIM iPads. Nobody was even taking them out to site because it was too difficult. So is BIM going to be the future? Absolutely. Is it relevant today? Sadly not, because it's not consistently employed or deployed across the buildings. So very few clients have enough understanding of what the power of BIM can do, so they don't insist that it's used consistently. So eventually we would, platforms like this would plug into BIM, and all of the naming, all of the normalization, all the tagging, all the ontology would be in place, and that task would be required. But I haven't come across a building today that is connected at that level.
So BIM will be your database, and what you go is like with your system, you do the right query on the database. But the problem is that today the foundation of that database is not there yet, correct?
Correct. So we would be using the BIM model to validate the data that's coming into the platform to ensure that everything is as it should be. You know, you can go into a building that you're expecting to see 100,000 data points and you can find 200,000, or conversely, you can find 50,000, and you need to understand why. So having a reliable BIM model speeds up the process of normalizing and understanding what you have versus what you should have. And then from there, you can start deploying the logic.
So the challenge today is not so much in the Internet of Things or the sensor, but it's more like, what do we do with those signals that are coming? Or you still have a lot of sensor that would be missing in order to enable to do what you want to do?
Yeah, absolutely. It's very difficult. So there's one side is the fact that there are so many sensors out there. You can go onto Google and look for an indoor air quality sensor, and you can find them from $5 to $15,000. Which is the one to buy? Depends on what you're looking to achieve. So a lot of the data that comes in from these sensors has to be taken with a reliable, heavy pinch of salt. So you need to make sure that you're using sensors that give you the level of quality of data and the granularity of data that achieves your goal. So you don't have to be spending $15,000 on a sensor. A $5 sensor might suit your particular purposes, but it's understanding again that the data quality coming out is reliable. So that's one element. And I'm sorry, I forgot the second part of your question.
Yeah, no, it was just to say, like, if the IoT is there or it's not there, right? Because it seems that, like you say, we have a lot of data points. Is that sufficient? And like you say, we have a choice of sensor, whether we apply them and things like that. I believe it's you need to start the design of your building with the operation in mind. But the question is, what is the most, if you had to design or if you had to approach a building, is the challenge more focusing on, we have enough data point, we need to structure the data properly, or we also need to have more data points?
You'd be amazed how much data you already have in a building, but because it's locked away in the BMS or it's locked away in the EMS, so it's only used by the individuals that are working on those systems, and it's not made available. Eventually, businesses will realize data is actually a company asset. It's a very essential part of the holding for the building. So we've seen clients who want to keep all of the data from the operations of their building, so that when they sell the building, they can sell that data on to show how the building's been operated. In terms of the Internet of Things and how many sensors do you need, I would always recommend that a person starts with the data they have, look at the journey they're trying to take. If it's purely around optimization, if it's purely around energy saving, or it's purely around wellness and indoor air quality, and then look at the gaps in that data before they go off spending tens of thousands of dollars on new sensing that isn't necessarily important to them.
Yeah, it's. I think you. Did you put a poll?
There is another poll popped up. Yep.
Yeah, that's one.
But feel free to ask any other questions. Somebody that isn't Pierre. Otherwise, next time we just have a beer together and talk. Yeah, so taking tech to the next level, it's about understanding the need. So with post-COVID, with the hybrid working environment, people now want to be able to change the way their buildings operate, because the way a typical building was designed, installed and commissioned was to be running 5 days a week, or in Singapore 5.5 days a week, and at from 7 till 5. And that's not the case anymore. You see, Mondays tend to be very quiet, Fridays tend to be quite quiet, and then it peaks up around Wednesday. So the building operators still have to deliver conditions that are within their contracts to their occupants, to their clients, but they need to be able to do it as efficiently as possible. So if they add occupancy sensors, people counting systems, they can start to understand how many people are in a space. They can start to condition the air based on how many people are in the space. And that means they can save considerable money, particularly in Singapore, where you're bringing in very humid, hot outside air that takes a lot to treat and bring down to the conditions called out by BCA.
Yeah, I agree with you. Like, I'm in an office building, and what terribly annoys me is that we have cool air 6 days a week. So not on Sunday, because how people have decided that we don't need cool air. But maybe we never go in the office on Monday, Tuesday, and we might have to do something on Sunday. So I'm sure that from an automation perspective, there is a capability to give me cool air on Sunday. And I think that's what is expected today from a a user perspective, right, is to be more agile in the way we are energy efficient and not defining when you need to be in the office by forcing the green building mark to you in your operation hour, right? So our aircon is from 8 a.m. to 6 p.m. After that, you don't have aircon and you don't have it on Sunday, which I find a bit sad.
Yeah, and as you say, with hybrid working now, you can't really dictate if people are not going to come in on Sundays because it's a global marketplace, and there's always something going on. So the chances of people needing to have access to the offices on Sunday is quite high. Most of our office space is in co-working spaces, and you can go in there. And because the people are working with either different time zones or different organizations, they're in the offices at the weekend, they're in the offices in the evening, and just having the aircon shut off at 6 is ridiculous. But it's the way the systems were programmed originally. And in 3 years' time, when you get the next buildings that are being designed today start to come online, you'll see that they're a lot more adaptable, or you would hope that you will see that they're a lot more adaptable. But the ones that are in existence today, they need to be reconfigured and reprogrammed in order to be able to adapt in that manner.
So maybe one more question for me. In your whole journey, like, getting access to the IT, getting people allowing you to sniff the data, and then after really doing the analytic. So what is the more or less, right, the time you need for each of those phases? Because the real value added is the data analytic, right? So how long is that data analytic compared to the whole previous journey, and what can we do better to get far to that point?
Yeah, so if you say the onboarding process to scan the building takes 12 to 24 hours, depending on the side of the building, the number of data points within the building, and the speed of the network. So you can have an initial report within 48 hours of the digital readiness of the building. From there, you start the ingestion and the mapping. If the protocols that have been used within the building are open protocols such as BACnet, Modbus, or it's a direct MQTT or API call, then the ingestion data is very fast. If they're a locked out proprietary system, then you have to develop an integration that goes with that in order to do the translation, and dependent on how complex that language is, it could take you a couple of weeks. Generally speaking, we see that 30 days from connection is when you start deploying logic, and once you've deployed logic is when you can start running your analytics and doing your anomaly detection. So 30 to 60 is the first surfacing of value data, and then from there on you start moving into optimization and operational improvements.
So how many days do you need to spend with the IT and the building owner to be able to have those first 30 days? Because what we were trying to do is that we spent 6 months and we couldn't get access to the data, right? So today in a normal building, is it that complicated? And what's the average? Yeah. And what is the loophole?
It is that complicated because previously the BMS system would have been on its own discrete network, the fire alarm would have been on its own discrete network, the lighting again, its own discrete network. Now everything's on a single converged network. So you have an integrated network which everything is on, and it's very difficult to say. The commercial systems, a lot of work, a lot of early adopters for platforms such as this are banks, and they have their corporate systems on the same network as their BMS. And obviously there's very valid concerns around security. So getting the CIO involved early on. Ordinarily, these decisions to purchase platforms like these are made at C-suite level. So you need to have in of the chief information officer or the chief IT officer. And once they've understood the process, once they've understood the rigorous testing that has been applied, then it's a question of communication with their team. So ordinarily for a large enterprise, you're probably looking at around 4 weeks of discussions backwards and forth to satisfy everybody that the platform is secure, their non-building data is secure, more importantly, and that interactions between the digital platform and their building systems aren't going to have an adverse impact on either the operation of the building or the other data that's traveling on that network. So around a month.
Which is the next question. If you need months to make the decision and like 2 or 3 months to first analytic, how come not everybody is doing it?
Because at the moment, everybody's looking at alternative means. So we can just offset this. Let's go buy some carbon credits, because that's a lot faster. You don't have to get approval from IT, and it just seems like an easy way to do it. The reality is that isn't a solution. So companies, there's companies who get it, and they're applying, digitalization. They have their own internal digital teams that are looking at how they can surface the data from their assets and make that data available to the widest possible audience within the company. So not just the C-suite, not just the sustainability team, but HR, so they can start to understand about, deeper about the wellness programs that they may have going on within the company, and really using that data for the benefit of the organization. So with those companies, it's a lot faster, because you have the authority from management direct to say that this is the path that we're taking. So those companies, it's faster, but a standard company that's just beginning this journey, it does tend to be slower. But many of them just will try and find another way. Even in the current environment, fuel in the US is still considerably cheaper than it is elsewhere. So a building that's operated by a company that let out all the space, optimizing the building, the only people that are going to see the benefit of that is their tenants. So why would they be interested? So what you have to have is the impetus from their board to say that we as a company want to do better, we want to be better. And it's only when you get that change mindset coming down from the top that you really get the call to action from the rest of the company.
Thanks, man.
No problem. All right, we'll give everybody else another opportunity to speak up. At least give us a clue if it helped you, if it informed you in any way. Is there something you'd like to learn more of? It's a tough audience. I like it when they shout at me. Okay, well, if we have no other questions, I believe the slide deck will be made available after the call, and there was a link to one of the asset management pages that were there. So if you have any questions, my contact details on the screen. Do feel free to reach out to me, or alternatively, you can ask Pierre and he'll ask me. For joining today, and as I say, I hope it was of some value to you.
Thank you very much.
Thanks, Derek.
Yep. Thank you.
Have a good
Thank you very much, Derek. Bye-bye.
Bye.
Thank you. Well deserved.
Thank you. Bye.
Thank you.